points, not all the points of our portion, but I hope, inshallah, it will be helpful. Let's go, Bismillah. We studied together the frame of reference, and we said that the frame of reference is a system for specifying the precise location of an object in space and time. And we said if you are in a car and you're observing an event, so the car is considered to be a frame of reference. If you are observing the event from the window of your class, so the class is a frame of reference, and so on. We said that the one-dimensional motion is the simplest form of motion, and we said that it's motion forward, backward, up, down, and so on. Well, we will agree together that the motion forward or right will be positive, and this is the opposite will be negative, and motion up will be positive, and the down will be negative, and so on. Now let's talk about the scalar and vector quantities. The scalar and vector quantities are the quantities, the scalar quantity, it's the quantity that has only magnitude. The vector quantity, it has a magnitude and direction. I think it's clear, and we explained it several times. But you have to observe that all these quantities, mass, distance, speed, work, you have to memorize them as scalar quantities. And all these quantities, position, displacement, velocity, acceleration, momentum, and force, you have to memorize them as examples of vector quantities. But now the question is, if we add a scalar to a scalar, the result is called sum. For example, we say 3 plus 4, the result is 7. So it's sum. We have no problem with such a method. But what about adding vector quantity? If we add a vector quantity to a vector quantity, we will have something which is called, concentrate, we will call vector sum or resultant. Okay, so the resultant is the vector sum of two or more vectors. Well, to understand that more, let's see this example. If I ask you what is 3 meters plus 4 meters equals 7 meters, this is a scalar, so it's a distance. This is another scalar, so it's a distance. This is the sum of them, okay? But what about this case? If the object is moving 3 meters right, then 4 meters up. If I ask you what is the total or resultant vector, which is the displacement, in fact, we will go in this direction to find the displacement, and using Pythagorean theorem, we will find it will not be 7. In fact, it's 5 meters. In fact, it's 5 meters. So here, 3 meters right plus 4 meters up doesn't equal 7, equal to 7, but it equals 5 meters in this direction. So this is not sum. This is a vector sum, which is called a resultant. So the idea now is how to find resultant, mister. How to find resultant. To find resultant, we have two methods. We may use the calculations of algebra, but this is not included in our quarter. It will be included, inshallah, next quarter. But we may use the graphical methods. And the graphical methods in our syllabus are only two. One is called triangle method, and the other is called parallelogram method. The parallelogram is also out of our portion this quarter, but the triangle with us, inshallah. So let's go back to our previous slide. Adding vectors graphically. To add vectors graphically, we will use the method of a triangle method, or the tip to tail, or which we call the head to tail. And when I say graphically, please concentrate, listen well. Graphically means no calculations. Graphically means just draw or sketch and measure using a ruler, using a protractor, and so on. Don't use calculations. This is in our portion, inshallah, Rabbul Alameen. Okay, let's talk about the first one. The first one is tip to tail or head to tail. And let me remind you, parallelogram, inshallah, will be studied, inshallah, next quarter. Okay, tip to tail or head to tail. To understand this tip to tail, let's see these three vectors, A, B, and C. A, B, and C. Regardless, the connection between A and B, they are connected together at this point. I'm not interested in this. They are two vectors, and this is the third vector. And I want you to find A plus B minus C. This is called resultant. Why, Mr. Resultant? Because it has addition and subtraction. If it's addition only, it's a resultant. If it's subtraction only, it's also resultant. Well, let's see. Now, inshallah, we will follow the steps. Number one, draw any of these vectors starting origin point. Which vector? Mr. Should I begin with A? No. A, B, or C, as you like. I told you any. So drag or take any of these and draw it beginning the origin point. Well, so we will drag, let's use A. Okay, A. We'll drag A along its direction. The same direction, parallel to its direction, the same direction and the same side. So this is A. So here we drag the A. Well, then the next step, oppose any subtracted vectors. For example, if the vector is minus B, you have to make the opposite of B. Well, let's look here. It's A plus B minus C. So the C is subtracted. So this is subtracted. So we will oppose C. So if this is C, this is minus C. Well, the third step is to drag the second vector, anyone also, keeping its size and direction such that its tip meets the tail of the first vector, or the opposite. What does it mean by opposite? Maybe its tail meets the tip. The most important idea: tip to tail, tip to tail, tail to tip, tail to tip, not tail to tail, nor tip to tip. So let's drag B. Okay, now we will drag B. We'll drag B. Drag means we will keep its direction. We will keep its direction and size. You see, this is what? This is B. So we drag the B here. Now, minus C. So we will drag minus C. Here, this is minus C. Where is the resultant? Repeat this step for all vectors. Okay, we dragged A, we dragged the B, then C. If there is D, we'll drag D, and so on. How can we find the resultant? Be careful. Resultant, draw the resultant from where, mister? From the first tail. This is the first tail. I have only remaining tail. To the last tip. This is the last tip. There is no other tips. Okay? Connect them. So this is the resultant. This is the resultant, which is A plus B minus C, which is A plus B minus C. So this is the method of adding vectors using graphical method. Well, Mr. If I transform or transmit C here instead of here, is there a problem? Yes. Why? Because this tail will be adjacent or in touch with this tail. And we said tip to tail or tail to tip. Okay, you can transmit it here. Anywhere. If you keep tip to tail, tip to tail, tip to tail, the remaining will be tail and tip. To find the resultant, connect the tail to the tip using or by a vector. This vector is the resultant. For example, so the sequence between A, B, and C, C, B, and A, C, A, and B is not important. It will give you the same answer. Well. Now, inshallah, we will study simple cases of tip to tail. These three cases are if the two vectors are in the same direction, if the two vectors are in opposite directions, if the two vectors are 90 degrees apart, as we see. We will study the first case. The first case, the two objects in the same direction. Let's read the problem. A person walks 40 centimeters. So this is the vector 1, 40 centimeters in positive x direction. Pauses and then walks an additional 30, not centimeters, I'm so sorry, meters, not centimeters. 30 meters in positive x direction. Determine graphically the magnitude and the direction of the person's placement. Imagine I'll sketch the first, not the first, but the second vector. This is what? 30 meters. Mister, you begin with the second. Yes. Why, Mister? Because the sequence is not important. This is the 40. Well, so we have a tail and a tip. The resultant is from what to what? From the tail to tip. The resultant is from what to what? From the tail to tip. From the tail to tip. Look, so this is the resultant. It's from the tail to tip. So the resultant here equals 30 meters plus 40 meters equals 70 meters to right. You get the idea? Well, let's talk about the second case where the two vectors pointing opposite in the opposite directions. In opposite directions. 4 meters. 4 meters in positive x direction, 40 meters in positive x direction. So this is 40 meters in positive x direction and 30 meters, but in negative x direction. You have to observe that we used the this is 40 meters in positive, and this is 30 meters, so it's negative. We make the tip of this one to the tail of the second one. Where is the resultant? The resultant is from tail to tip. So the resultant is from tail to tip. Where is the tail? The remaining tail. This is the remaining tail. Where is the remaining tip? This is the remaining tip. So where is the resultant? It's from here to here. So this is the resultant. It's the difference between them. So R equal 40 minus 30 equal 10 meters. Well, if the two vectors are 90 degrees apart, for example, an object moves 100 meters in positive x direction. So this is 100 meters. And then moves 100 meters in the positive y direction. 100 meters. Okay, determine graphically the magnitude and the direction of the. So this is it will be 100 square root of 2. It will be the resultant. By the way, if the two objects are coming out from the same point, like this, the two forces are coming out from the same point. If I want to find the resultant, what will I do? I'll do like this. I'll keep this here and make this is tip to tail, tip to tail, tail to tail. So I want to make it tip to tail. So I'll drag it up here like this. Okay, so this will be the resultant. Well, now inshallah we will talk about this set 2 question sample. Which of the following vectors, this is set 2 question sample, which of the following vectors best represents the vector A plus B? These are the two vectors and these are the choices. To solve this question, let's do the following. We will drag A here. This is A. And we will drag B parallel to its direction and keeping its length here, such that the tail of B at the tip of A. So now we have only one tail and only one tip. So we will connect them to get the resultant A plus B. So which one represents this? I think it's clear. A is the one that represents this. This will be, inshallah, the second part of our revision. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.